The formula for finding the angle between two vectors is given to you on your formula sheet, so you don't have to have that memorised. Now, when you looked at the formula, hopefully you noticed that you are actually familiar with more of it than you would realise. You just need to learn how to apply it. So if the formula's got the magnitude of each of your vectors, we know how to find magnitude, and it's also got your scalar product, which we've been looking at a little bit more recently. So you have to know the magnitude of each of your vectors and the scalar product of these vectors. You can then apply that to your formula and rearrange using your knowledge of trig from last year. So first thing we're going to do for this one, we're given two vectors u and v, and we're finding the angle between them, and they're both given in unit form. So start off, we're going to find the magnitude of u. So the magnitude of u is each of your components squared, added together and square rooted. So we've got 4i, so 4 squared, plus j on its own, so plus 1 squared, and then plus negative 2k, so we've got negative 2 squared. Always watch out for your negatives. So that's going to give us a square root of 16 plus 1 plus 4, which means the magnitude of u is root 21. We're going to do the same for v. So we've got the square root of, so we've got 5i, so we've got 5 squared, another j on its own, so plus 1 squared, and then we don't have any k, so we've got 0 squared at the end there. 5 squared is 25, plus 1 squared, so 26 is the magnitude of v. We can then find our scalar product. So remember, your scalar product or your dot product, u dot v, equals each of your components multiplied together and then added. So multiply your i's together. So we've got 4 times 5 plus our j's, which is 1 times 1, plus our k's, which is negative 2 times by 0. 4 times 5 is 20, plus 1 times 1, plus negative 2 times 0. So our scalar product is 21. So we can now move on to look at our formula. So we've got cos theta equals u dot v over the magnitude of u times the magnitude of v. So again, remember that is given to you on your formula sheet. You just need to know how to apply everything to it. So cos theta is going to be equal to, so u dot v is 21. That's our scalar product that we've just calculated. The magnitude of u is root 21. And we're timesing that by the magnitude of v, which is root 26. Thinking about how you solve a trig equation, we're not looking for cos theta, we're looking for theta on its own. So to get theta on its own, we're going to find cos inverse, and it's going to be cos inverse of everything that we've just put down. So our dot product over our two magnitudes. When you put that into your calculator, you'll get 26.01 degrees. So the angle between the vectors u and v is 26.01 degrees. So the second kind is where you could be given 3 points. Now, when you're given 3 points, you need to think back to the angle between your vectors. Now, remember, it was very, very important that your arrows on your diagram pointed in the same direction. So if we're asked to find KLM, that means we're asked to find this angle in here. So it's very important that both our arrows are pointing away from L, as they are in this one. Or if you weren't given any arrows, if you weren't given your diagram, then you need to make sure that you can point them in the same direction yourself. So either both pointing away or both pointing towards. So for this one, we are going to be finding the vector L to K. And we're going to be finding the vector L to M. So again, that's very important based on the fact that my vectors have an arrow pointing away from this L. Alternatively, you could have found K to L and M to L. Okay. Now, the reason that we're doing this is because our formula has the magnitude of a vector and it has the scalar product of your vectors. Now, you can only do that between two different vectors. Right now, we just have our points. We have to find the vectors of these. So for L to K, remember, is going to be K minus L, which is 1, negative 7, 2, minus negative 3, 3, 4. And that gives us 4 minus 10, negative 2. L to M is M minus L, which is 251 minus negative 334. And that gives us 5, 2, negative 3. So these are the two vectors that we're going to be using, okay? So our formula is changing slightly, and that we're now having to replace parts of it. So on your formula sheet, it would have A dot B. We don't have A's and B's. In the last example, we had U's and V's, so we put U dot V. But in this example, we're going to have LK dot LM. So we're just replacing everything with the letters that we've got. So we're then going to have it over the magnitude of LK and the magnitude of LM. Okay, so you're doing the same thing, it's just that you've got different letters, and in this case you've got 2 letters for each part. So things that we need to know the magnitude of LK. So the magnitude of LK is going to be 4 squared plus negative 10 squared plus negative 2 squared. Always watch out for your negatives. So we've got 16 plus 100 plus 4, which gives us root 120. So the magnitude of LK is 120. We need to do the magnitude of LM. So the exact same way, 5 squared plus 2 squared plus negative 3 squared. That's going to give us root 25 plus 4 plus 9, which gives us root 38. Final part is your scalar product. So we've got our LK dot LM, so multiplying your components together and then adding them. So we've got 4 times 5 plus negative 10 times 2 plus negative 2 times negative 3, and that's going to work out to be 20 minus 20 plus 6. So our scalar product is 6. We can then substitute it into our formula. So we've got cos theta equals, so the scalar product is 6 over the magnitude of LK, which is 120, root 120, times by root 38, which is the magnitude of LM. We don't want cos theta, we want theta. So remember, you're then going to take cos inverse, and because I'm running out of space, I'm just going to put an arrow of that. So that would all go into your calculator. And you can then figure out that the angle between these two vectors is 84.9. And that's my final answer.